So on this video, we're going to be talking about how to solve radical equations. Again, this should be a little bit of review for you guys. When it comes to solving these equations, the first thing you always want to do is isolate the radical. In this particular example on number one, it's already isolated, but if it wasn't, that's what you would want to do. And then you want to raise it to a power of whatever the root is, or the index, and then you want to do that to both sides. But I want you to kind of think about why we're doing that. So I want you to think about this as 15 minus 2x. And if I were to rewrite this without the radical, well, that would just be to the 1/2 power is equal to x. So these are the same thing, just rewritten. One has a radical and one has a rational exponent. So that is why you are doing number two, which says to raise it to a power of the root. And in this case, the root is 2. So if I were to raise it to that power, I would essentially cancel it out. So if I'm raising this to a power of 2, then the square and the square root cancel out, and I'm left with 15 minus 2x is equal to x squared. Same idea as if I were to take this and raise it to the reciprocal power, and we would get the same thing. So that's where that comes from. Now we know that it is quadratic, so now you just go through and solve as usual. So depending on where you are in this particular instance, this particular equation, since it's quadratic, I'm going to set it equal to 0. So I'm just going to move all of these guys over to the other side so that I get x squared plus 2x minus 15 equals 0. And so from here, I can try to see if it's factorable. I do believe it is. It would be x plus 5, x minus 3. And then I can go ahead and solve, and I would get x plus 5 equals 0, which means x is equal to negative 5. And then I also get x minus 3 is equal to 0, and x is equal to 3. However, this is very, very important. You always need to go back and check for extraneous solutions. And extraneous just means that you have an extra wrong answer. All right, so what we need to do is go over here. I'm going to move this over a little bit. And now I'm just going to write check. So you can do this on your paper. So what I'm going to do is take the original problem. So you always want to take it back to the original problem. And I'm going to say check where x equals negative 5. So let's check that. So negative 2 times negative 5. And does that equal negative 5? So let's take a look. Some of you can already see that something's wrong here. But we'll discuss that in just a moment. So we've got the square root of 25. Is that equal to negative 5? We got 5 equal to negative 5, and that is not the case. Think about it. Whatever is in that radical, there's no way if I were to take the square root of that I'm going to end up with a negative. Okay, so kind of pay attention to that, but definitely check. So we know that 5 is not going to, or negative 5 is not going to be our answer. So now let's double check when x is equal to 3. So you plug it into the original, and we are checking to see if that also equals x, which is 3. So 15 minus 6 gives us the square root of 9. Is that equal to 3? 3 does equal 3, so I can box my answer of x equals 3. Okay, so now what are we going to do if we have radicals on, or more than one radical in an equation? So it's very similar. We still need to isolate a radical. So what I'm going to do is I'm just going to isolate this one right here, which means I need to move over this other radical to the other side. So I'm going to get the square root of 2x plus 3 is equal to 4 minus the square root of x minus 2. Now what we want to do is focus on getting rid of that radical, so we are going to square both sides. And you may need to do a little bit more multiplying on that right side, but when we square this radical, it's always nice to have where it cancels. So I get 2x plus 3. Now let's just do a little bit of work off to the side. If I have 4 minus the square root of x minus 2 and I'm squaring it, now you definitely can multiply it out, absolutely, but I am going to use the pattern of the a plus or a minus b squared, which simply says a squared minus 2ab plus b squared, right? So, and you can look that back up into your previous notes from section 1.5, I believe. All right, so this is rather quickly going to give me, it's like saying 16, right? Because I'm going to square that 4. And then I multiply these two together and then double it. So that's going to be minus 8 rad x minus 2. And then I'm going to get a plus, because when I square that negative, it's going to be a plus. And then when I square that radical, it will cancel out. So I end up with whatever's my radicand. And so now I just need to simplify that. And I'm going to get, let's start with negative 8 rad x minus 2 plus x plus 14. So that looks a little messy, and it is, but we're going to get there. Negative 8 square root of x minus 2 plus x plus 14. And so at this particular spot, I've done that. I've isolated my radical on the left and I squared both sides. So now notice that we still have another radical. So again, we've got to now isolate this second radical. So I am going to subtract x and subtract 14 to both sides. So I end up with x minus 11 is equal to negative 8 square root of x minus 2. So from here, now you could square both sides at this point, and that's fine, or you could also divide by negative 8. If you end up squaring that, you end up having a fraction, so it's kind of up to you how you want to present it, but you can definitely square both sides now. So if I were to square x minus 11, that's going to give me, again, utilizing that property, that a minus b squared, it's x squared, multiply these two together and double it, so negative 22x plus 121. Negative 8 squared is 64 times, and then this is going to cancel, and I get x minus 2. So I've got x squared minus 22x plus 121 is equal to 64x minus 128. So notice that it is quadratic because we have x squared. So I am going to subtract 64x and add 128 so that it is equal to 0. So I end up getting x squared minus 86x plus 249, and that is equal to 0. You can factor and solve. I'm just going to save you some time. I will factor this for you. It's x minus 3 and x minus 83. You could always use the quadratic formula to solve this. So what we get is x is equal to 3 or x is equal to 83. But we need to check. So it's very, very important that we check. So let's go ahead and check. I'm going to check x is equal to 3 first. Plug it back into the original problem, not after you've isolated it. Everywhere where there's an x, I put parentheses. Now I'm just going to go ahead and simplify that, I get 6 plus 3, and then rad 1, so that's rad 9 plus rad 1, so 3 plus 1 does indeed equal 4, so I can box that. Now let me go back over here. I'm going to check 83. So let's plug it in. We've got 2 times 83 plus 3 plus 83 minus 2, and does that equal 4? So 83 times 2 is 166 plus 3, and then 83 minus 2 is 81. That gives me 169 plus rad 81. I know that this is 9 and this is 13. 13 plus 9 is 22. 22 does not equal 4. So that means this guy right here is extraneous.